Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we're looking at the 54th Project Euler problem. As always, I will link to the problem and my repo in the description. Let's dive in. Problem 54 is about poker hands. In the card game poker, a hand consists of 5 cards, and they are ranked from lowest to highest in the following way. And it gives this list here. The cards are valued in the order 2 through ace. Ace is high. If 2 players have the same ranked hands, then the rank made up of the highest value wins. For example, a pair of 8s beats a pair of 5s. See example 1 below, where we have a pair of 5s and a pair of 8s. But if 2 ranks tie, for example, both players have a pair of queens, then the highest cards in each hand are compared. See example 4, where we have pairs of queens with a 9 and a 7. Player 1 is winning. If the highest cards tie, then the next highest cards are compared, and so on. The file, poker.txt, contains 1,000 random hands dealt to 2 players. Each line of the file contains 10 cards separated by a single space. The first 5 are player 1's cards, and the last 5 are player 2's cards. You can assume that all hands are valid, no invalid characters or repeated cards. Each player's hand is in no specific order, and in each hand there is a clear winner. How many hands does player 1 win? Okay. So full disclosure, I actually did start working on this, but I wasn't recording my screen share. So I've got quite a bit of stuff down here. I copied over the question and the rules of poker ordering here so I can work off of it easily. I created a couple of dictionaries for the suits and the values so that I could sort a hand based on that. And basically in sort hand, what I'm doing is I'm creating a new array with 52 empty strings, and then getting, based on the value and the suit of the card, putting the card at the proper index in that array, and then I just remove all of the empty strings and return new hand. Maybe not the most efficient way of doing things, but it does work, I'm pretty sure. So I then also have an is flush method, which gets the suit from the first card in the hand, and then for each card in the hand we check to see if any of the cards in the hand do not contain that suit, then it is not a flush, because a flush is defined as all cards of the same suit. And there's a couple of special types of flush, but we'll get there in a minute. And then, of course, I have my printing of the timestamp, my count variable, so that we can count how many hands player 1 wins. Currently, it's actually counting how many hands are flushes, but that's going to change. And then I have this with open the file as f, and then for every line, read in the cards, split the cards into 2 hands using this neat Python annotation. And then the step that I'm working on is evaluate the score of the hands, because the difficulty in this problem, it's not really mathematical in the same way, but the difficulty of this problem is creating a poker engine. A poker scoring engine. So let's see. What we really want is to be able to have a method here where we get a score, and then only if the two scores are equal do we like try to figure out which is the high card. Or whatever. So two different pairs. Okay. Let's go ahead and create is straight, taking in the hand, and then hand equals sort hand. And then I could honestly just call this from the very beginning. And I kind of like that better rather than calling it in multiple places throughout the code. Okay, so if is straight hand equals hand 0 0 I'm gonna go ahead and have it do this. So what that will do is it'll have the index of this. And then okay, so for I in range, we're going to start with 1, and we're going through 5, so, or, actually no, it's not an index 5. And then val equals values, hand of I, first character is the value, if val is equal to next val plus equal 1. Alright, let's do it this way. If val not equal next val, return false, and then otherwise next val plus equals 1, and if we get all the way through and have not hit our if condition, then we are dealing with a straight. Okay, so so royal flush is a straight flush that begins with a 10. So I'm not sure this is the best way of doing this, but 0 equals t. So that is a royal flush. Actually, let's go ahead and define that's actually just this first part. Right. Gotta finish your function. So that's is royal flush and is straight flush. Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 different types of hands. So we're just going to score them 1 through 10. Royal flush, and then return 10 if is straight flush, and return 9 and then 4 of a kind. Call this find num values, and what this is going to do is for card in hand, we're going to make this dictionary and this is basically going to help us solve the full house, the 4 of a kind, the 3 of the kind, and everything else. Below that, so we're going to have this be num vals is a dictionary. And val is card at index 0, and num vals at val is going to equal num vals dot get default. We set that as equal to 0, then I think if we do this, it'll just work perfectly. Or maybe it's... we can just do that. And then we return num vowels. So let's see. So then if numvals dot values for in, I forgot the +1 here. That would have made it not work at all. And that is the 8th highest hand, yes? Yep. So 3 full house is 3 of a kind and a pair. So that's if 3 in numvals dot values and 2 in numvals dot values. Return 7. And then flush. Flush. Return 6. And I think the next one is straight, so if it is straight, return 5. It does prefer you actually call your functions properly with the parameters and stuff, which is fair and valid, because otherwise it doesn't know how to work. Okay, so 3 of a kind is next. So that would be if 3 vowels dot values. 4. And then 2 pairs. So that's so 1 pair and 2 pair. So I am going to do if 2 in numvals dot values, and then see if there's a second one. And then return 1. Count equals 0 for val in numvals dot values. If val equals 2, count plus equals 1. Now, this seems really inefficient, and I don't know how well it will work. Count is equal to 2. Then return 3. Okay, so this is going to be our scoring, just for right now. Score 1 equals score hand 1. Score 2 equals score hand 2. If score 1 equals score 2, I am going to go ahead and print hand 1, hand 2. Else if score 1 is greater than score 2, count plus equals 1, because we are counting Okay, so obviously this isn't gonna really work, because if these scores are equivalent, I should be doing further evaluation, not just being like, which one's bigger, but let's see what this gives us. Okay, so we call score hand. String index out of range. Okay, I feel like we were dealing with this. I'm just gonna count length. Let's see. Ah, so this is not working properly. And that's because I needed to be using something like a remove all. Does not seem to be a function. Let's see if I can just put it in there. Okay. Okay, so Python remove all from list. let's see. Okay, so I could count them and then go through and remove all of them. Okay, removing specific element from list using list comprehension. This is probably the one that's going to be easiest. Yeah. I'm just going to make this C for card. It really does not matter in the slightest. I just want my variable names to be good. Okay, so we counted 235, but look at all of these ones that had the same score. So, obviously not what we want. Go ahead and delete this, which we only added for debugging. Okay, so for this one, let's see, we got the 10 spades, the 4 of spades, 9 of hearts, king of clubs, and the 8 of clubs. So I think these two are both high card, and that might be the major thing here. Okay, so if they're the same, which means they're both one of these. So let's think about the values that we've put on this stuff. So highest value card, that could be a score of, I'm going to say 2 through 11, 12, 13, 14. So highest value card. Oh, wait a second. I have this backwards, I think. So this is straight the way I do next value. No, because I'm using the same values here, so it's fine. But this should be 4, I think. I'm gonna switch this. Okay. I'm gonna go ahead and turn this around also, even though the suits don't matter. And now it'll sort the hands from smallest to largest instead of largest to smallest. Which, because it's the way that it is. So, kind of what I'm thinking here is, what's a good secondary scoring mechanism? Because obviously if we're in this scenario, if the score is, like if we have kind of a straight or three of a kind, or really anything here, like if we're comparing two fours of a kind, we want to look at the ones that are not in the four of a kind. So what I might do is score based on what the index value is here. Which should automatically mean a higher value for any of these. And that'll give us unique high values. Let's see if it gives us the correct answer, though. So now we don't even really need to sort. Instead, what we're going to do is say for card in hand, score equals 0. Score equals this will not work. This will not work because you could have a high card be something different. So let's see. Bring that all back. Obviously, there's quite a few here where we had this sort of equal score from our original test. Let's see. Reading the rules again real quick. If two players have the same ranked hands, then the rank made up of the highest value wins. So like if we were comparing two straight flushes, I assume the one with the highest card wins. Four of a kind, it would be like through 4 aces versus 4 kings, the aces would win. Okay. But I think we need to have it in this method somehow. evaluate hands. So, because they promised us that it would be clear, royal flush, only one player can have a royal flush in order for it to be clear who won. Because of the same values thing. Okay, so if is straight flush, hand 1. So if they are both straight flush, then we evaluate the value of the first card in each hand. So, hand 1. Where did that say this way? Values. Two. Return hand 1. Else. Return hand 2. I feel like we don't even need the else here. Yeah, we do not. Non-vowels 1. Do the same thing for 2. Okay. F4 and non-vowels 1, not values. Actually, this I'm just going to rename to evaluate winner. It's going to be the same thing here. If val 1 is equal to val 1 equals val 2 equals 0. 1, if num_vals 1, key of val is equal to 4, val 1 equals val. Literally the exact same thing over again for val 2. This needs some serious refactoring, I think. But for right now, I'm just kind of working through it. Val 1 is greater than val 2, return and 1. Else if val 1 is equal to val 2, num_vals 1 dot remove. Can I just comp item val 1 num_vals 2 comp item val 2. Yeah, this is maybe not the world's best way of doing things, but that's fine. Num_vals 1 dot keys 0 val 1. I'm gonna do the same thing for val 2. And the reason I know this will work is because it's a 4. The other one is going to be a 1. Greater than val 2, return and 1, else return and 2. Again, we have a promise that it is a clear winner, so we know they can't be equal, or at least theoretically they shouldn't be able to be equal. Okay. So this is literally the exact same thing over and over. So we're gonna have to figure out how to, like, refactor this into better code, I think. Or maybe I'll decide to not do that, but in any case... think if we have a 3 of a kind and a pair, then it is reasonable to assume that adding the values of those two will always give us larger numbers. So like if we had a 3 3s and 2 2s, that would be in our values array or dictionary, that would be 1. Whereas if we had 3 aces and 2 8s, that would be an 18. So I think, well, maybe not. There might be a scenario where it wouldn't work out quite that way. Val 4 3 1 equals val 4 3 2 equals 0. And I'm going to do the exact same thing for 2. And then I am going to say very similar to this. If num_vals val equals 3, then val 4 3 1 is equal to values val plus val for 2 1 equals values val. Exact same thing for 2. Again, we know that it has to be either the 3 or the 2, so because there's only 5 cards in hand, so we're just kind of building in some stuff here that's maybe kind of an assumption. And then we're going to say if val for 3 1 is greater than val for 2 1, or 3 2 it should be. Return hand 1. This wrong, else if val for 3 1 is equal to val for 3 2, then we check for this. Otherwise, we return hand 2, and otherwise we return hand 2. Okay, so we're getting there. We're getting there slowly but surely. This is going to take a lot less time to run than it is to type it out this way, I think. But yeah. Okay, so if hand 1 is a flush, I have to go remember what a flush means. All cards of the same suit. So similar to the straight flush, where, well, maybe not completely similar. All cards of the same suit. If both players have a flush, that means that we compare the high card. And the high card is always going to be the last one in the hand for a flush because they're all the same suit. Okay. So if both hands are flushes, then val 1 is going to be I could just compare this in one line, but flush is the one where it's the same suit, right? Yep. And then straight is consecutive values. So I don't actually have the straight thing quite correct, I don't think. But let's keep going with it for now. 1 is greater than val 2. Return hand 1. Otherwise, we return hand 2. Nothing else to evaluate there, it just becomes high card. And then it is straight hand 1. Okay, so if they are both straights, all cards are consecutive values, then I think that that means, again, we just compare high card. So exactly the same logic as here. Because I have this sorted by value and suit, I don't think this will actually work. This is straight method, but we're gonna go ahead and let it cook for right now. And sort of see what shakes out. Okay, so copy this part. This time I'm going to say high 1 equals high 2 equals 0. So basically what I'm doing here is I am getting both the value for the 3 of a kind and the high card in case I need it, just to reduce the number of calculations. Okay. So now, if val for 3, 1 is greater than val for 3, 2, I can just return hand 1. Else, if val for 3, 1 is equal to val for 3, 2, then I have to compare high. So I think that will work. This is probably an unnecessary return statement. But, again. Okay. I'm going to break this out into a function. Let's say define is pair of pairs. And that is going to take in a hand and a num vowels. And then I'm just gonna guess it only needs the num vowels. If count equals return true, else return false. Don't actually need the else. Okay. So, if this pair of pairs I think this is fine. That was one. Then we have to see if this pair of pairs num vowels 2. If it is not, we return hand 1. Otherwise, we have to see. I'm just gonna move this up a level. Make it its own little section. Okay, so if is pair of pairs for both have a pair of pairs, then we have to evaluate the values effectively. So I'm going to try this a little bit differently, and I am going to do scores 1 is equal to val for val in, I know I have another list comprehension that's a little complex somewhere in this code. Yeah, C for C in new hand if C does not equal. Okay. We're gonna do something similar to that. Okay, so val in num vals 1. And actually this is going to be values val. And I'm going to do the exact same thing for 2. And then scores 1 equals scores 1 dot sort, and then scores 2 dot sort, and then a pair of pairs is going to end up having 3 distinct values here. So we want to say if scores 1 at index 2 is greater than scores 2 at index 2, return hand 1. Otherwise, if those two are equal, we just compare the next one. Scores 1 of 1 is equal to scores 2 of 2. Then otherwise, if we get to here, it's not hand 1 and it is hand 2. Okay. So otherwise we just have pairs to evaluate. I'm gonna grab these again. Actually, this is literally the exact same logic. Except we don't know that it's 3. We just have range, length, actually no, we do know, we know that it is in fact 4. So we could add another layer here, but I think it would be better to do it this way. Length of scores 1 minus 1, negative 1, negative 1. And just say if scores 1 of I is greater than scores 2 of I, return hand 1. Otherwise, if scores 2 of I is greater than scores 1 of I, return hand 2. And if we get all the way to the bottom of this loop without having returned anything, that means that hand 2 is the winner, because we hit a bunch of equals. Okay, so I think that will work as far as it goes. As I've been saying, the straight isn't correct. And I'm gonna go ahead and do this free factor right now. Okay, so evaluate winner of hands. Winner equals, I'm going to say winning hand equals evaluate winner, hand 1, hand 2, and then this is just going to be if winning hand equals hand 1. Then we add to the count, and that's it. List index out of range. Interesting. How could that be possible? If we get to here, it should be a 2 and 3 ones. If we get to here, it's 2 2s and a 1. So how could we possibly go here? I'm going to go ahead and right up here at the tippity top do print, and this is going to be a print that I'm going to regret, and I'm going to have to run it again without it. But now evaluating hand 1 versus hand 2. And that'll give me exactly what hands we're running into this issue with. Okay, so here's one pair. Ooh. A 1 pair versus a 2 pair. Okay. So I had not considered So obviously I'm doing this kind of all wrong. Because I'm just saying, oh, if hand 1 is a royal flush, then it's hand 1. If hand 2 is a royal flush, and I'm only evaluating whether hand 2 is a straight flush if it is straight flush, hand 2, return hand 2. So this is kind of what I have to do for all of these. 4 in numvals 2 dot values, return hand 2. And again, like, I feel like there's a better way of doing this. Right now I'm trying to make sure that it works. This actually is missing a return hand 1, so obviously this isn't a great way of doing this because this code is confusing. Straight hand 2, return hand 2. Otherwise, we have to do this high card evaluation. And I'm kind of having it default to hand 2 as the winner, but okay, 4 and numvals 2 dot values. I forgot to do the parentheses. This is why I copy and paste, to avoid mistakes like that. Alright, so we got 362, and I am going to guess that that is the incorrect answer, because I don't think my function for is straight is quite correct. But let's go ahead and see. Nope, not the correct answer. So, as I said, is straight hand. I'm going to do actually here. Vals equals val. I'm not gonna try to do this as a list comprehension. Val 4. see. 0, 4, C in here. And first val is vals 0. Actually, now I think I can just do val as I. Okay, so let's see if that gives us a different number, not 362. It did not. So I'm going to do a print here and say found a straight, and I'm going to delete this other print statement. Okay, so we're not finding any straights whatsoever, which seems incorrect, right? Let's try throwing a vals.sort on here and see if that fixes it. Okay, now we're finding straights and we got 359. I'm much more confident that this is correct. Run that one more time. And this obviously has a runtime that we can be pretty proud of. It's very, very quick. But is it the correct answer? It's taken a while to think about it. Taken a while. Goodness. Alright. So I think there's some really obvious flaws in this code. For one thing, there's clearly a lot of duplication. There's clearly a lot of evaluating things more than one time. I think there's a lot that I could do here to improve this. And the answer isn't correct anyway, so let's see if we can keep this going. So I'm confident that is straight is correct now. I think is flush is right. But maybe this evaluate winner function isn't working right. Is there a single royal flush in this entire thing? I don't think there is, honestly. Let's see. Okay, so obviously if either hand is a royal flush, that's the hand that wins. But it looks like we might not have any royal flushes. I'm gonna look for is flush. And I'm gonna do a little printy print. Found a flush. Okay, so we're finding some flushes. None of these are royal flushes. So that's probably fine. here. So between hand 1 and hand 2, found winner to be winning hand. Gonna delete the found flush part. Okay, so yeah, this is probably too much data to just kind of glance at and find the correct answer. Okay, thinking it through again. One of these is getting an incorrect answer out of 1,000. At least one. It's probably a category of errors. So I bet this is the problem right here. So I was looking hand 1, first card. That's not in our values dictionary. But we're still getting the same answer. So maybe not quite. Still thinking there's probably a much simpler way of doing this. So straight flush is consecutive values of the same suit. Oh goodness. The animals have begun to riot. So this should work. And then we double check that whether hand 2 is a straight flush. Flush is it flush when it's all the same suit? Okay, so is flush everything's the same suit? We want to see whether the highest value card is greater. So there is a problem here. If they're the same, we should compare the next card. So let's go find this. So those are the keys. We're just comparing the different values. This should work just fine. And we want to do the exact same thing here. I really think this is unnecessary. We should have a clear liner somewhere along the line because of the promise of the thing, but we shall see. Okay, let's see if we are getting a different number now. Still 359. Find winner by high val. Num-vals 1, num-vals 2. Okay, so now everywhere where we have something like that, we can instead say if find winner by high val winner by high val, I'm going to say is equal to find winner by high val, num-vals 1, and num-vals 2. Redo. Return hand 1. Otherwise, return hand 2. Okay. So we're starting to look a little cleaner if we do all that every time. Okay. That should not function differently, but it does. Cool, 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 cool. Okay. That is because now we've opened it up to the possibility of having two different... Okay, find winner by high val. Okay. Let's do this a different way. Let's say wow scores 1 or scores 2. Score 1 is equal to scores 1 dot pop. And actually this should be an and. Then score 2 is scores 2 dot pop. And then if score 1 is greater than score 2, return 1. Otherwise, if score 2 is greater than score 1, return 2. Otherwise, they equal and we compare the next two values. We're still getting that 359, which we already found was the wrong answer. But let's see. Alright, now I'm just kind of looking for other refactoring options, perhaps. So, if we have 3... So this might not be what we want here. So as you can tell, I'm kind of not really sure on this one. I think what I have going here with this finding the num vals thing is pretty close to what we need. Because it tells us how many there are of each value, which is a lot of what we need. But there's also clearly some things where we're not doing it right. So, what if in here I did that thing with the scoring? I'll have to move this up a bit. If I do that. Let's see if that gives us a different number. It does not. I'm going to go ahead and put this in for all of these scenarios and see what that gets us. I am expecting it to be a different number. I am not expecting it to be the correct number, but let's find out. It's the same number. Okay, I'm going to double check that we actually did look at 359. Okay, we did, and that is not the correct answer. We could just start guessing, but that's not how we win this. The issue here is I'm really not sure where we're going wrong. And short of just stabbing at the dark, I'm not quite certain how to figure it out either. I think we might not need to worry about straight flush, to be honest. Okay. Now I'm going to do something similar for all these other ones. pair. Okay. So, awful lot of two of a kind here. Let's see how many of these seem to be correct. So, two of a kind. This is a 10. This is a jack. Winner is 2. That is correct. And there's literally nothing other than two of a kind listed. Which I find very strange, don't you? I think we'd at least have something else where we have to compare both of them. Just to double check, let's check a few of these just to see. So here's ace, so the winner is 2. Because ace versus 6, ace is always going to win. Here's a jack, a pair of jacks versus a pair of 3s. The jacks should have won. This is incorrect. So, something is a bit off in that comparison. Let's see, they both have kings, but this has an ace, that's why. Okay, so we have to compare the pairs first if we want to be doing it this way. Obviously, the winner by high val isn't always correct. We actually want to sort our dictionary by values first. Okay, so that's the issue, is we have to go by whatever one is there the most times, as well as whichever one is there. Okay. Find num vals. I'm going to say nums equals val for val in numVals dot values. Basically, I'm trying to sort this dictionary so it's more useful. What's the best way to do this? First, we find these num values, find winner by high val. So, only thinking about the pair. And let's just do this for the one place where it matters. One. Yeah, val 1 is going to be val in vals 1 dot values if val equals 2, and I know that there's only going to be one of those, so go ahead and do it this way. And then if val 1, actually I want this to be values. Okay, and then if val 1 is great, that meant to be that val 1 is greater than val 2, return hand 1, and then if val 2 is greater than val 1, return hand 2, otherwise we do winner by big val, or winner by high val. Which may or may not give us the correct answer, but should at least get closer. Okay, 376. Is this the correct answer? And it is. Okay, so with a larger set of things to compare, and obviously we got there, and it's well within a minute. Well within a second, honestly. If we had more hands in this than what do we have, 1,000? Yeah, 1,000. And they included things like they're both a 3 and a 2, this algorithm would not work. Which means it's not a very great algorithm for evaluating these things. But we did solve the problem. So I think the main thing is this just isn't a very good poker scoring algorithm. It works well within time, but if we had an expanded set of data, like if we had, let's see, a 3 and a 2, so like let's say ace of spades, ace of clubs, ace of diamonds, 2 of diamonds, 2 of hearts. And then they had king, 2 of clubs, 2 of spades, just to have them both be 2s. Would we get the correct answer for that last one? So, the winner here should be... Actually, just to make this a little bit... Well, the 3 of a kinds can't be the same, so... There's only 4 of them in a deck. Let's see if we get 377. Okay, so it did work for that one, because the 3s are the higher value. So what if we had 2 here and aces here, and then like 3s and 4s. I'm honestly not 100% sure what the correct answer for this would be. This is a clear winner for the 3 of a kind. This is the clear winner for the 2. Let's see what our algorithm says. Algorithm says it's the one with the 2 aces, which feels correct to me. Let's look at our rules, such as they are. Then the rank made up of the highest value wins. I mean, obviously that's a pretty extreme case, but I'm gonna call it there for today, since this is 2 hours long already, and I'll see you in the next one.